Betelgeuse, the enormous red supergiant star that marks the shoulder of Orion, has long been a source of fascination for astronomers, stargazers, and anyone with even a casual interest in the night sky. Its glowing, reddish hue is unmistakable, standing out against the surrounding stars in the Orion constellation. But Betelgeuse is not merely a beautiful point of light. It is a cosmic giant nearing the end of its extraordinary life. In recent years, this star has displayed peculiar and unpredictable behavior that has captured the attention of scientists and the general public alike. What makes Betelgeuse so remarkable is not only its immense size and luminosity but also the tantalizing possibility that it may explode in a supernova within a time frame that could allow humans to witness one of the most spectacular cosmic events imaginable. To appreciate the scale of Betelgeuse, it is essential to understand just how massive this star truly is. If it were placed at the center of our own solar system, its outer surface would extend well beyond the orbit of Mars, engulfing Mercury, Venus, and Earth. It is one of the largest stars observable from our solar system, and because it is relatively close at approximately 650 light-years away, astronomers have an unprecedented opportunity to study its late-stage evolution in detail. Betelgeuse belongs to the class of stars known as red supergiants, a category of stars characterized by their enormous size, relatively low surface temperatures, and an accelerated, unstable phase of stellar evolution. Betelgeuse is a semi-regular variable star, which means that its brightness changes over time. Unlike a perfectly stable star like our Sun, Betelgeuse's light output fluctuates due to complex processes occurring in its interior. These fluctuations can be relatively mild or incredibly dramatic, resulting in significant changes in how the star appears from Earth. Between 2019 and 2020, Betelgeuse underwent an extraordinary phenomenon known as the Great Dimming. During this period, its brightness dropped sharply, leaving astronomers puzzled about the cause. While the star has always exhibited variability, this event was unprecedented in recent history, leading scientists to speculate about potential mechanisms such as surface cooling, massive ejections of stellar material, or even a prelude to a supernova. Then, as if to defy expectations, Betelgeuse began to brighten again, sometimes dramatically, catching the attention of professional astronomers and amateur stargazers alike. On May 20, 2023, a Twitter account called BetelBots, which monitors the star using data from the American Association of Variable Star Observers, reported an incredible 142% increase in brightness. This was not just a minor fluctuation, it was a signal that Betelgeuse was undergoing dynamic changes in its outer layers, possibly shedding mass and reshaping its structure. Astrophysicist Andrea Dupree from the Harvard-Smithsonian Center for Astrophysics explains that these observations place Betelgeuse among the brightest stars in the night sky, climbing from its usual 10th position to 7th. For observers in the southern hemisphere, Betelgeuse can now be seen glowing vividly at dusk, while in the northern hemisphere, it becomes more prominent as the nights grow longer. The excitement surrounding Betelgeuse lies not only in its fluctuations but also in the tantalizing prospect of witnessing a supernova. A supernova occurs when a massive star exhausts its nuclear fuel, and its core collapses under the force of gravity, triggering a catastrophic explosion. This explosion releases an enormous amount of energy, briefly outshining entire galaxies and scattering heavy elements across the cosmos. For Earth-bound observers, the event would be visible even without telescopes, and depending on its proximity and intensity, it could cast shadows at night. The anticipation of this cosmic spectacle has astronomers monitoring Betelgeuse more closely than ever before, recording every pulse, fluctuation, and anomaly. Betelgeuse's life cycle is both fascinating and complex. As a red supergiant, it has evolved far beyond the main sequence phase that our Sun is currently in. Its core is undergoing a series of fusion reactions that convert lighter elements into heavier ones. Currently, Betelgeuse is fusing helium into carbon, producing energy and creating an increasingly heavy core. As time progresses, the star will fuse carbon and helium into oxygen, then oxygen into silicon, and eventually form an iron core. This sequence of reactions generates immense pressure and heat, creating instability in the star's outer layers. Eventually, the core will no longer be able to withstand the gravitational forces, leading to a catastrophic collapse followed by a supernova explosion. The final remnant may become a neutron star or a black hole, depending on the star's remaining mass at the time of collapse. The Great Dimming event and the subsequent increase in brightness provide critical insights into the processes occurring in Betelgeuse's outer layers. Observations suggest that during this period, the star ejected a significant portion of its atmosphere, creating turbulent regions and dust clouds that temporarily obscured its light. These events, while unusual, are not necessarily indicative of an imminent supernova, but they do offer scientists an unprecedented opportunity to study the pre-supernova behavior of a red supergiant in detail. For centuries, astronomers have relied on theoretical models to predict the life cycles of massive stars. But Betelgeuse allows for direct observation of these processes, offering insights that were previously impossible. Throughout history, human cultures have noticed Betelgeuse's variable nature. Ancient Greek and Aboriginal Australian astronomers recorded its cyclical changes, noting periods of increased and decreased brightness. Today, modern telescopes and space-based observatories provide far more precise measurements, allowing astronomers to monitor changes in brightness, surface temperature, radial velocity, and mass ejections. The typical brightness cycle for Betelgeuse lasts around 400 days, but since the Great Dimming, this period has shortened to approximately 130 days, reflecting significant changes in the star's behavior. These rapid fluctuations have sparked renewed interest in predicting the star's future and understanding the underlying mechanisms driving these changes. Despite decades of observation and advanced technology, predicting exactly when Betelgeuse will explode remains impossible. Professor Peter Grower from the University of Portsmouth emphasizes that while scientists understand the processes leading to a supernova, no one can determine the exact moment of detonation. It could occur tomorrow, or it may take tens of thousands of years. This uncertainty adds to the fascination and drama surrounding Betelgeuse, making it a star that continues to captivate imaginations around the world. Observers today are witnessing a star in a state of flux, providing a unique opportunity to study the late stages of stellar evolution in real time. The potential supernova of Betelgeuse carries immense scientific importance. A supernova produces elements heavier than iron, which are essential for the formation of planets and life as we know it. These elements are dispersed into the interstellar medium, contributing to the cosmic cycle of star formation and planetary development. By studying Betelgeuse's behavior and eventual supernova, astronomers can gain valuable insights into stellar nucleosynthesis, the formation of neutron stars and black holes, and the dynamic processes that shape galaxies. Betelgeuse thus represents both a spectacular celestial event and a laboratory for understanding the fundamental mechanisms of the universe. For amateur astronomers and skywatchers, observing Betelgeuse is a thrilling experience. Its fiery glow stands out in the Orion constellation, easily visible with the naked eye. Those in the southern hemisphere can enjoy its brilliance at dusk, while observers in the northern hemisphere will notice it growing more prominent during the longer nights of winter. The rapid and dramatic changes in brightness create an ever-evolving spectacle, allowing observers to witness the star's life cycle unfold before their eyes. Every dimming and brightening serves as a reminder of the powerful forces at work within this stellar giant. The mythology surrounding Orion and its stars adds another layer of intrigue. Orion, the hunter in Greek mythology, is depicted as a formidable figure in the night sky, and Betelgeuse marks one of his shoulders. Throughout history, civilizations have imbued these celestial bodies with stories, connecting human culture with the cosmos. Today, the combination of mythology, history, and cutting-edge science makes Betelgeuse a star of enduring fascination, bridging the gap between imagination and empirical study. Betelgeuse is also a symbol of the interconnectedness of the universe. The elements produced in its core will one day seed new stars, planets, and possibly life itself. By observing this star, humanity gains insight into processes that occurred billions of years ago and will continue to shape the cosmos long after our lifetimes. Its evolution reminds us that the universe is not static but a dynamic, ever-changing environment where creation and destruction are intertwined in an ongoing cosmic dance. In conclusion, Betelgeuse is far more than a distant point of light. It is a cosmic giant undergoing one of the most dramatic phases in stellar evolution. Its fluctuations, recent great dimming, and potential for a supernova provide an unparalleled opportunity for observation and study. As astronomers continue to monitor its every pulse and variation, Betelgeuse serves as a window into the life and death of massive stars, offering insights that were previously only theoretical. The eventual supernova, whenever it occurs, will be a cosmic event of unprecedented scale, visible from Earth and providing valuable scientific data for generations to come. For those fascinated by the wonders of the universe, the drama of stellar evolution, and the extraordinary phenomena of massive stars like Betelgeuse, subscribe to our channel, hit the like button, and turn on notifications. Follow along as we track the ever-changing sky, explore the secrets of the cosmos, and witness the extraordinary events that define the universe. Betelgeuse's story is still unfolding, and the next chapter could be the most spectacular in human history, revealing the beauty, power, and unpredictability of the stars in ways never before seen.